So as we had our derivatives before, we managed to look into this part where we are differentiating, but the simplification is not required. So this is a typical exam that we are going to consider, which is from our August 2014. So like I said from the previous class that we had, if you have got a certain question from a question paper like that you have been doing, but you still do not get sense of that question, you can comment on that so that we can work on that question paper on a separate class so that we can understand that together. All right, so I'm not going to waste much time, guys. We had the basics of this part, but now it's a typical exam. They are saying determine dy dx in each of the following cases. Simplification is not required. The simplification is not required at the end. All right, do not worry about that. Let us consider what we are given. The first part we are given, y is equal to tan squared the square root of 1 minus 3x. So in the previous class, I had like a way that we can just choose to follow. Remember, I said we can rewrite this. If you're given a squared, like tan squared, it simply means you have got something like this. Y is equal to tan. This is our function as it is, the square root of 1 minus 3x. But we are focused, or we are focusing on a tan. So it means the whole of this tan like this is being squared, the square there, that is there. All right. So it is just like we are given to the exponent of 5 sine to the exponent of 5x like this. It is the same sine x to the exponent of 5. So someone might ask, what about the square root of sine x? It is the same thing. It means the sine of x, everything to the exponent of a half. Not x being, we are not talking about x there. The square root is affecting the whole of a sine. The exponent there is affecting the whole of a sine. So this one, it is the same as the sine to the exponent of a half like this x. It is the same thing, same presentation, just like here. So you see that part. So when you are given that, you're supposed to rewrite in that manner so that you understand that the whole of this tan is raised to a certain power. Remember what I said, considering when you've got a power like this, you start or you work with the power. You focus on the power as if the tan is not there. How do you differentiate the power? Remember the derivative, guys, or when you're given a power, y is equal to x to the exponent of n. The derivative with respect to x is what? N, x to the exponent of n minus 1. So you drop the power, you subtract 1. This is what I'm trying to say. So it was going to be like this. The derivative of y with respect to x is equal to, we drop our power, then we subtract 1. So it was going to be 2. This one, just read it as it is, as if it's not there, guys. Rewrite as it is. So it's tan the square root of 1 minus 3x to the exponent of what? 2 minus 1. So 2 minus 1 was going to give us what? A 1. So it's now to the exponent of 1. Okay? This is what we're going to have. You are considering what? You are focusing on the power. But whatever that you're going to have, you're supposed to multiply to the derivative with respect to x of what? That function that you're ignoring. You were concentrating on the power. Now, on this as it is, what is it that we are seeing there? It is the tan square root 1 minus 3x. This is what you're given like this. This is what you're given, guys. You're supposed to differentiate this. So the question is, how do we differentiate this? Guys, it's a new question, this one. It's a new question. If they can give you this one alone, how are you going to differentiate it? Just like what we had. We focus with what? This time, we do not have it as tan to the exponent of, it's 1 there, guys. So it's not like we're going to focus with that tan, then we drop the water, we're going to have nothing. So we do not have the power, just like the previous case. So how do we differentiate? We are going to focus on a tan, this one. Ignore this. We ignore it. Remember your function of function. This was going to be our function now. So we take it just like the previous case. We ignore it, this one, the square root of 1 minus 3x. We focus on a what? On a tan. So we are differentiating a tan with respect to what we are ignoring with respect to this. Okay, guys, let me write this. You understand me? dy dx is equal to, we rewrite this one, 2. So as we can see, raised to the exponent of 1, guys, does not affect because it simply means tan to the exponent of 1 there. So this one does not affect. It is just same as what? Tan the square root of 1 minus 3x. Here, we have simplified, nothing special there. All right. We multiply to this derivative that we are supposed to have. But this is what I'm trying to explain here, to say that you were going to focus on a tan. All right. That's our trick there. We focus on that tan to say the derivative of a tan with respect to, it is with respect to this, meaning to say we are ignoring that function. We are just focused on a tan. So remember, a tan gives us what? When we differentiate, the derivative of a tan is going to be what? Sec squared. All right. Where's our formula sheet, guys? Here. Tan, the derivative there is going to be what? Sec squared. So it is supposed to give you what? A sec squared. So this was supposed to be sec squared of what? This was, you are ignoring that function. You are differentiating with respect to this. So it remains as it is. Make sure that you watch the introduction, guys, when I was talking about differentiating. Maybe you're given sine of 2x, where I said you can differentiate sine of 2x with respect to x. With respect to 2x. Then you differentiate the 2x, this one, with respect to x now on its own. So this is what we just did here. We differentiated a tan, the whole of this tan, but with respect to what? To this. So it means we just, okay, tan changes to a what? Tan changes to sec squared when differentiated. But there's something that is remaining there. There's something that is remaining that has to be differentiated. The function. So it is just like here, guys. When we differentiated according to the power, this part that is, this one that is shaded, we are supposed to what? To differentiate it with respect to x. But as we are differentiating it with respect to x, it gives us the same thing. So we're supposed to differentiate this part that we shaded here as our function. We are supposed to have that with respect to x. We differentiate the square root of what? 1 minus 3x. This is where we are. We are supposed to differentiate this. You understand, guys? We are going back to the answer. Do not worry. Do not simplify, just rewrite. dy dx is going to be what this time? 2 tan the square root of 1 minus 3x times sec squared, the square root of 1 minus 3x times, we are differentiating this. But as we are differentiating this part, remember how it can be written as this one. It can be written as what? 1 minus 3x to the exponent of a half. Take note. So as we are differentiating it, we are focusing like this. This is what we are focused now. Look, guys, we are back again. So guys, you see that part. We have to consider it again. This one as a function on its own, raised to a certain power. There is a power there. How do we differentiate? We drop the power. So we're back because we're supposed to differentiate this, but there's a power. It's the square root, it's same as a power. So we drop the power, remember? So this is what we're going to have. Half of what? 1 minus 3x to the exponent of what? On our power, we subtract 1. We are focused on the power, not the inside of the bracket, the power. So it was going to give us what? A negative half. But remember, as we are differentiating focused on the power, there is a function that we are ignoring. What are we supposed to do with that? We are supposed to differentiate that function with respect to x. We were ignoring this. So we are supposed to differentiate it with respect to x until we are done. That is what it means. So we differentiated looking into the power. Then we differentiate the function that was being covered by that power. We have to differentiate it. So this is it. So here, I'm just going to rewrite, guys. We are almost there. We are almost there. We are almost there. So this will be our final stage of our answer. Let me do this so that everything can be seen. All right. So this will be our final stage. So let us differentiate and finish up this question. So therefore, our derivative with respect to x, divide x, is 2 tan the square root of 1 minus 3x times this part as it is, which is the sec squared, the square root of 1 minus 3x. Yes, guys, they say do not simplify, but these ones, guys, to the exponent of minus half, you can also simplify that one. Remember, it simply means 1 over the 2 is already in the denominator. This one is just like 1 over 2 times 1 over 1 minus 3x to the exponent of a half. But we do understand to the exponent of a half, it means what? The square root as it was before. So it's going to be 2 times this, which is the square root of what? 1 minus 3x. But if you do not know this part, leave it like this. They will mark it. They will mark that one, all right? If you do not know how to simplify that, then leave it like that, all right? Times. Here we differentiate. This one is just a linear, guys. The derivative of 1, that's a 0 there. The derivative of minus 3x with respect to x is what? Minus 3. Remember, these ones are, guys, are your basics. So we're done. There is nothing that we can do further. There's nothing that we can do further when it is like this. So you see how you work out these questions, guys. If you know this concept, guys, you're not going to have a challenge if you know this. Because some of us, we are not understanding. When we simplify, I'll be taking the whole of the question at once. I differentiate at once. Then you'll be like, now, what is this guy doing? So if you do not understand what I was been doing before, this is what you can do. Stage by stage, stage by stage, stage by stage, up to the last part. Make sure that each part is considered. Do not leave any stage. All right, let's consider another question. As we saw, there are 2 questions that we are given there. So we are also going to consider the second part and see, using this approach or this technique, if it is going to be easier to use. It can be like there are so many steps, but those steps, guys, they are easy to follow. They are just like a follow-up from this one to another one, to another one, up to the end. All right, let's look into this one and see, using the same approach. There we are given, that's 2.22 of this question paper. We are given y is equal to the sine to the exponent of 3 of x over what? The ln of sine x. No problem, no problem. Let's see. So this is it. If we were to consider this, we can see that this is a function that we have to consider as what? The quotient rule, where the quotient rule can be used on this function. There is a function divided to another one, ux over vx, remember. I referred about this one, or I talked about this from our introduction, where I said you are supposed also to ought to remember those rules. Remember, from your product rule, the derivative with respect to x of y with respect to x is supposed to be given as v. You start with the denominator, then the derivative of u minus u, the derivative of v, all over what? V squared. Okay. This was exactly the formula that we're going to use. I want us to be careful here. Do not rush when you're answering these questions. Write your formula. Then as you are substituting now, that is where you're supposed to be careful. All right, let's substitute and see. We were going to have it like this. The derivative of y with respect to x is equal to v, which is our denominator. Are we seeing that there's nothing that is affected there? We are just taking our v as it is. So we are going to write as it is ln sine of x. As it is, all right? Let me just put a bracket, guys, so that it can make sense there. Ln sine as it is, all right? Times the derivative of u. I want us there to be careful now on the derivative of u. The derivative of u, let's look at our u. It is a certain part raised to a certain exponent, just like what we had here. So are you seeing that approach is where we're going to apply it? When you were to differentiate your u, because this u sine to the exponent of 3 is same as sine of x to the exponent of 3. So as we were going to differentiate our u with respect to x, we were going to look into what? The power. Remember, the power. We drop that power, all right? We subtract 1. Because we are considering this as our function to be represented as our u, like when we to use our function of a function. So we drop the power 3. This remains as it is. The sine of what? The sine of x as it is. To the exponent of what? We subtract 1 on our exponent. So 3 minus 1, that's a 2. You are focusing on the what? On the power. But thereafter, we are supposed to what? To multiply to the derivative with respect to x of what is the part that is raised to the exponent of 3, which is what? The sine of x. This is what we are going to have. This is what you're going to have. So what were you going to have? You're going to have this one. 3, guys, you can even simplify sine squared. When it is like this, it simply means what? Sine squared of x times the derivative with respect to x of this sine x with respect to x. Sine, remember, it gives us what? A cos. So this is what you're going to have. From this exponent, we have differentiated. So this whole part that we are seeing there of u, when being differentiated, you see, we're going to apply that stage again. So we're going to obtain what? 3 sine squared of x times the cos of x. This is what we're going to have. We have differentiated our u minus, all right? So our u, we are done. There's no way that we're going to differentiate that. Even if we need it, we have it, all right? Minus what? U. As it is this time, it is not different. It is just u. So we take our u as it is, sine to the exponent of 3x like this, times what? The derivative of v. Just like what we did on our u. Let's take our v aside. So we're going to take our v aside. V is equal to what? Or vx is the ln of sine x. So for you to understand, this is like this, ln sine x. So you're going to differentiate this. How do we differentiate a ln? Because we are focusing on a function, a ln. the derivative of a ln. How do we differentiate a ln? As for a ln, it's gonna depend with the way that you understand. But as for me, guys, I explained this one before, that if you're given ln f of x, you are differentiating with respect to x, and it's ln f of x, a function of x. You are going to take the first derivative of that f of x over what? Over f of x. So take note, ln f of x, the derivative of f of x over f of x. So in our case, this is our f of x, this one. It's ln sine x. So sine x is representing what? Our f of x. Sorry for that. It is representing our f of x, this one. So we need its derivative. What is the derivative of a sine? That is what? Cos of x over what? F of x. Our f of x is what? The sine. So over that sine as it is. So this is our derivative. We're done. We've differentiated a ln. There's nothing that we can do, guys. This is the derivative of a ln as it is. So there's nothing that you can do. Remember, guys, your derivative of what? A ln. So that's going to be cos of x over sine of x. Remember, simplification not required. We know that this one is going to give us a cot, but just leave it like that. So we have differentiated our v. But they are saying here, everything, every part is over what? That's over v squared. V as it is, but we have to square it. So our v is what? The ln of sine x as it is, but being what? Being squared. So we are going to square that one. Like I said, guys, the ln of sine x, you can even write it like this, ln sine x. This is what we are going to have at the end. There's nothing that we can do from there. Simplification is not required. We're done. So you see, guys, it is not that much. It is not that much. Follow the stages. Follow the stages. It's not even that much. So these questions, they carry a lot of marks, guys, in exam. They carry a lot of marks. So we are going to have more questions in our revisions. So make sure that you've got a question that is still having a challenge. You have worked with the introduction. You have worked with this video. Then you do that question. Then you see, no, still there's a challenge. Or maybe the answer that is in the memo, you are not understanding how it was done, or you are doubting that answer, because sometimes there can be errors from our memo. You can have errors. So you just comment on that question so I can look into it. So this is what we had, guys. Till we meet again.